Very good evening, guys. Let me know in the chat. You guys can hear and see me. Very good evening, Arad. Very good evening, Hariharan. It looks like today you guys are early, huh? Otherwise, I have seen you guys join little late. Hariharan and Arad, if I'm not wrong. Very good evening, Ekta. How you guys are doing? Okay, okay. Okay. I'm doing good, Hariharan. Thanks for asking. Very nice, Ekta. Very nice. So, so in the link list, is it? Does it look? Am I looking like tired to you guys? Because I personally feel I'm not. It might be some brightness on my screen. Less tired. Okay, okay. Yeah, yeah. Thank you, thank you. Yes, actually, weekend vibes. That's right. And very soon, actually, Diwali is also coming, right? You guys also, I think Anshul has told me, right? We are going to have a long vacation, 22, 22 or 21? Yeah, 22 to 25. So definitely. So this is just the next week, and after that, long vacation we have. So yes, I think this whole month is actually very exciting month. A lot of vacations, a lot of cleaning is going on in home, and festival of lights, as we say. So yeah. So yes. So you guys tell me. Yeah, yeah, definitely. So you guys tell me. I'm expecting you guys have practiced everything, right? All of the four scenarios you guys have practiced, and I also shared in the LinkedIn the stock span problem. Anyone practiced? Oh, Nilanjan, this is not good. If you are practicing linked list, you will be missing these things, which are very important. I told while leaving, I think when we are at the last seconds in our last class, I told at that time, whatever you are practicing, older concept, Node.js, linked list, just keep it away for some days, because whatever we are discussing right now, these questions you have to practice it, because these questions are has been asked in very big companies. So that's why do not skip these questions. Otherwise, you will be like what I say, when you will practicing these things, like after some time, you will not remember every logic there, right? And it will be waste of time. So that's why I'm saying whatever you are doing in the back, please keep it at a pause for some days and practice these questions. I think after that, after stack, we are going to start queues. In queues also, we will be having very nice questions which are being asked in tier one companies like Google, Amazon, Apple, Microsoft. So definitely this time practice all those problems. Okay. I just practice next grader element. Yeah, that's fine. If you have practiced these two problems, next grader, because today whatever we are going to solve, most of the questions are going to be depend on these things only. Next greater, next smaller, previous greater. All the questions are going to be based on that only. So actually, sir, due to heavy office work, I'm not getting time, but trying to get concepts. Okay, yeah, heavy office work, I can understand. But still, I'm also doing the office work. I'm also practicing things. So still, like I took some time off from the work and practice it. But yes, that's fine. That's okay. If it is like too much work is coming there, that's fine. It happens sometimes with me also when I didn't get time for 2 or 3 days. That's fine. That day you can just understand the concepts and you're attending the class. That's also nice. So for that I appreciate it, because sometimes it happens. I agree with that. Is stack and queue a linear list? Yes, actually, if you're saying linear list, So because see, stack and queues, they are going to internally have the contiguous memory, because we implement stack with the same concept which we are using in arrays. And for the arrays, we say that these are non-contiguous memories. So it means they are going to take all the space at the all the space in contiguous manner. So they are, in one way, they are linear only, right? Because as you are seeing the arrays in similar way, we are going to see the stack and queues also. Okay, but yes, in the because in the stack, the time complexities, pop and push operations, they take just the constant time. So I solved the stock span problem with very little external help, as I was getting the incorrect output. Ah, I see. That's fine. We'll see that today. Okay. So let's start, guys. Let's start, guys. Today's topic also. Today's also we have very nice questions actually, and we are going to think about them, those questions. And I'm again telling you guys, all those questions are going to be based on these concepts only. Okay. So let me first share my screen. You guys are able to see my screen? Let me know in the chat. Yeah. So first let's cover the last thing which we have discussed. This was a screenshot. I've taken the screenshot from my mobile and uploaded it in LinkedIn also. I'm sure you guys have seen it. But let's just revise these things, and then we will jump in directly into the questions. Okay. So what was the concepts which we were talking about these questions? So we started with this one, the right greater element or nearest greater element, right? We started from that question, and what are the strategy we need to use whenever we are talking about the greater element. So we discussed that always our loop will start from the end side. Whenever somebody is saying you have to look for find something from the right side, so always our loop will start from the end side. End side means where the element is ending. So we will start iterating from the back side to the front, or from the right side to the left. That's what, whenever somebody is asking you to look for the greater element, and look for the element on the right side, element on the right side. Okay. And when somebody is saying to you to look for the greater or lower, greater or slowest, greater or lower, yeah, greater or lower element on the left side, then always loop will start from the zeroth index. You can see all other places wherever we are saying the previous first greater element, or left, I'm not sure about the e, whatever we have taken the left uh, elements or something like that, left early element or something like that, we have taken this it as a, and you can see here also previous first lowest element. Oh, we have taken it as a, I think, lowest element. I think I missed it here. It could be something else, first or not sure. But yeah, you guys understood, right? Whenever we are talking about the left side, our loop has to start from the zeroth index. And whenever we are talking about the right side, we have to start our loop from the end side. One more difference, whenever we are like finding out our answer with the looping side, whenever we find the answer on the right side, we need to reverse it. These are the things which we need to remember. This was the differences between looking for right side or left side. Okay, we are good with that. Let me know. Let me check into this. Left greater element. Yeah, thank you. Yeah, it would be then G, right? I have written as it E. Thank you, Ligit. So, are we clear with that? These two topics, and then about the code. About the code, what I told. Whenever we are looking for the greater element, our stack element, our stack top or our stack peak element should be greater. Whenever we are looking for a greater element, our stack element, if our stack element is greater, we will not do any popping. We will not do any popping. We'll simply take that element from the stack and then insert the new one, right? And if our element is smaller than the current element which we are looking into the array, if our stack top element is smaller than the current element in the array, we will start doing the popping, and we will do the popping till first condition our stack is empty, or second condition if we got any peak element which is greater than the current element, because we started with when our element was smaller in the stack. At that time we started popping it out. We are popping it out. Every time we are checking it. Once our element is greater than, once our stack element is greater than the current element, we will stop the popping there. That was the condition for greater one. Same goes for the lower one also. Whenever we are trying to find the lower element, we will check that our stack top should have the lower element. And once you found the lower element, you will not do any popping. You will just simply take that as an answer, and you will push the next element. You will push the next element, and same goes for there. If you find out any greater element in the stack top, when you are looking for a smaller one, if you find out any greater, you will start doing the popping, and you will stop it. You will stop your popping only when you find any lower element. You will stop at that place. Everyone understood? Now everyone has the visualization about these logics. Everyone, I want the answer from everyone, because we are going to jump into the question. Everyone has good visualization on those things which we have discussed in our last class with the examples also, right? Okay, so I think do you want to start with any easy question, because all of the questions are, I think we have 4 or 5 questions. So do you guys want to start with the easy question first or with the hard one? You guys tell me which one you want to go with first. Easy one, right? Okay, let's jump into easy one. Okay, so this is the easy question. We'll not look it here. We'll simply look into the lead code. We'll read the question from there. Okay. It's an easy question according to lead code also. I already solved it, so let me now read it in front of you. So guys, it's very easy question, actually. Sorry, Vishal, we already got a lot of easy. So let's start with easy and let's finish it, and then we will jump into that one. It should not take, I think, more than 10 minutes, I believe. Let's see what. Let's see. So guys, this is this is the question. So they are giving you one string in the lower case, you can see there. And the question, you can read it here. Remove all adjacent duplicate in string. You have to remove all adjacent duplicate in string. So we see what is duplicate removal. They're saying they will be giving us a small letter string, a small English letter, and then they're saying a duplicate removal consists of choosing two adjacent and equal letter. Two adjacent and equal. Just go for my please on these line. Put your attention here. Two adjacent and equal letters and removing them. We repeatedly make duplicate removals on a string until we no longer have or no longer can. We need to remove those adjacent and equal letters. Till then, we do not have any letters. Till then, we do not have any duplicates or adjacent letters. Then they are saying return the final string after all duplicate removals have been made. It can be proven that answer is unique. Now let's see their example also. So you can see they are saying we have one string ABBACA. ABBACA. Let me write it in the here also. So it will be very quickly, we'll understand here also. So what they are saying, guys, we have one string ABBACA. Now what they are saying, we need to remove all the adjacent and duplicate letters. और हमें ये तब तक करना है, we have to do this thing till there is no duplicate adjacent letter in the string. So let's see. You can see first adjacent and duplicate letter which you will find, which is BB. Correct, guys? This is, you can see they are adjacent to each other and they are duplicate letter. So first we will remove these two letters. So once we will remove these two letters, the final string which we got, which will look like this, AACA. Correct, guys? Now again you can see two adjacent duplicate letters and we have to again remove them, right? So we will again remove them and then we will get next string, which is CA. Now you can see they are adjacent, but they are not duplicate. Right, guys? They are not duplicate. This was the first example. Let's take second example also. AZXXZY. AZXXZY. X, X, Z, Y. So the first duplicate element, which are also adjacent, which is this one, X, X. They are adjacent and duplicate. So let's first remove these two. Once we will remove them, the string, final string will look like this. Then again we find it out two adjacent letters. Again we'll remove them and we will get the final string as a XAY. Guys, you can see the answer. Everyone understood the question? Let me check in the chat. Okay, so Hariharan is saying something. So sir, sorry to interrupt. For next greater element, stack top should have lesser element, right? Or greater element. For next greater element, stack top should always have the greater element. For greater, stack should always have the greater element. Then we will not do any popping. We will not do any popping. जब भी ग्रेटर एलिमेंट आएगा हम उसको सीधे आंसर में ले लेंगे और फिर हम अपना लूप को आगे बढ़ा देंगे, स्टैक में उस एलिमेंट को पुश कर देंगे, जिसके लिए हम चेक कर रहे थे. ओके, so always we need to check for greater element in the stack. Understood, Hariharan? Which one? Deepak, you mean the question? Lead code, yeah. Okay. So Deepak, the question was saying we will be giving one string, and in that string we need to remove adjacent and duplicate letters. This is the condition: adjacent and duplicate. They are not saying duplicate only. They are saying those letters should be adjacent and duplicate. That's why I was saying this was the AND condition. This was very important condition here. So that's why we started looking into this string. So first we find out A. Okay, this is the first string, first letter. Then we find out B. Okay, we are good. Then we found again B. So then we are checking with the previous one. Is it the adjacent one of this? Yes, it is. And is it the duplicate? Yes, it is. So we will remove these two letters. So once we remove these two letters, now the new string looks like this: AACA. Right, guys? And once we got this AACA, again we are checking the same thing from the starting. So A, okay, this is the first letter. Then we went for second letter. Is it the adjacent and duplicate? Yes, it is. We'll remove them too. And then we got the final string, which are adjacent but not duplicate. Same goes here also. We started from A, we went for Z, those are not adjacent and duplicate. Then we went for X, X and Z are also not adjacent and duplicate, are adjacent but not duplicate. And then XX, we got the duplicate. So we will remove these two, and then we will got AZZY. Then we will remove ZZ and we will get the AY final. Hope you understood the question. Understood, Deepak? What about others? Vishal, Nilanjan, Suraj, Arad. Got it? Okay. It was not okay. Let's try this first. Okay, you guys want to give some ideas, so I can wait for 2 minutes. We can wait for 2 minutes. Okay, so Likit has given one suggestion. Yes, actually, 2 minutes would be good, right? Take on while infinite loop, okay. Take stack, okay. And if loop show so that the pointer is at the end or not, to check whether any element is adjacent, push one by one and check if the top is equal to element pushing, and if they are equal, pop element and don't push the element and repeat the loop from side. Yes, that's totally right. Likit has given the correct answer. That's what we are going to do it. That was very, very straightforward answer. I know you guys have seen it, right? I showed you the way also. You have to start from A. So guys, it's just straightforward. Like I know this is like let's think about it, because we are already read about the stack, right? How the stack works. In the stack, we push one element like A. That element will become our top, right? That element or that position will become top. So before pushing any element, we can check always the top element. We can always check our stack peak element. So that's what. So first time we will push, like for this string, A, B, B, A, C, A. So first time we will push A. Okay, that's the first time we have pushed it. Let's look for B now. Okay, so now before pushing into the stack, just check with the top. is it the adjacent or duplicate or not? That's what you need to check. Or see, because you are already pushing only the adjacent element, that's why you do not need to check any condition for adjacent, because only the next element will be pushed into the stack. So you just need to check for duplicate. So is B equal to A? No. So just simply push B. Simply push B, because B is not equal to A. Now our top has become B. Now our top will change from A to B. We have already seen these things, right? Whenever we insert a new element in our stack, our top change. Now let's go for second B. Now we again find out the B. We'll compare it. Is both this character and top is equal? Yes. Simply pop it out. Simply pop this B from here and do not push anything and go for the next later. And then again we will see this A or this A is equal. Our top will also go to down, because once we pop out, you know that our top also got to bottom element. Now we'll check for this A. A and A is, yes, again they are matching. It means we need to again pop it. We need to again pop it. So now our stack is empty. Now we'll go for C. There is nothing in the stack. Simply push it. C, we pushed it. Now go for A. A or C are matching? No. Simply push it. Then our answer would be C and A. This would be our answer. The final elements in the stack, that would be our answer every time. Okay. Let's first see that, and then we'll understand AZ, XX, ZY also. But let me see in the chat. Did you guys find it difficult? You have to iterate into the string. You have to iterate into the string. Take first letter. When the stack is empty, just push it, and then go for the next element. Why AC? Why not ABC? Who was that? Riaz. So Riaz, because we have already popped out B, because these B already we have popped out, and as you can see, these B were adjacent element. You can see these B were adjacent element. So we need to delete those adjacent element. So that's why we do not have B in a B. That's why we have already popped them. You can see here. You can understand here with these answers why we do not have B, because we have to, because these B are adjacent element, adjacent and duplicate element. So we have to. That was our question. We need to delete adjacent and duplicate element. Let's see here, guys. Let's quickly see here. We'll start our loop from first element. We'll see our stack is empty. Simply push it. Our stack is empty. That's why first element is pushed out. Now look for second iteration, which was this Z. So before pushing, we'll check our Z is matching with A. No, simply push it. If it is not matching, simply push it. Now look for X. Is X matching with J? No, simply push it. Now X, is it matching with matching with that slack top element? Yes, it is. We will simply pop it out. Whenever things are matching, we'll simply. Array, why the eraser is not coming? Weird, huh? Yeah. So whenever any matching element is coming, you just simply need to pop it. Now look for next Z. You see Z and Z again they are matching, so we have to again pop it. Again Z has been popped out. Now we'll see for Y. Y is not matching with A. We'll insert the Y, and our answer would be YA. We'll take like print our element like this, or A by, like, sorry, from the bottom we'll print like this. Like that's based on our answer AY. That's why our answer will be AY. Hope everyone understood. Understood, everyone? I can also do the coding very quickly. It's not tough. It's not tough. Let's do very quickly. So let's look for first condition, because string length could be 1. So if string length is equal to 1, we'll simply return that string, because whatever that string is, it's not adjacent and duplicate, because duplicate can be when the length is 2. So if the string is simply nothing much, right? If s dot length is yes, okay. Now what we need to do, we need to create one stack, which would be our array. You're already aware of it, right? Then put a loop on string let char of s, right? Now if stack is empty, if stack dot length is equal to 0, what we need to do? We simply need to push our stack. We simply need to push that character. Correct? That's what we did. Whenever a stack is empty, we are simply pushing it. So first time our stack will be empty here. We'll simply push the A there. Correct? Now our stack is empty. Now else if stack dot length is greater than 0. If our stack dot length is greater than 0 and stack top element stack dot length -1. That's how I already showed you, right, in the last class, how we see the stack top element. So stack top element is equal to char, which we are looking. If both are matching, simply do the pop, stack dot pop. Correct? That's what we need to do, guys. These are the two operations. If stack length is empty, then we need, oh yeah, one more condition is there. If this is not the case, we also have to push it. So what we can do, guys, we can remove this condition. Actually, we do not need this condition because 1 minute, let me think about it. Yeah, we do not need this condition. Actually, we need this. 1 minute, guys. What we will do, we will first check for if stack dot length is greater than 0, means when stack is not empty, and stack dot length -1 is equal to character, we will pop it. Else we always have to push, right? Stack dot push and that character, right, guys? This is by default. Every time we need to push it. You can see if our stack dot length is empty, we need to push. If this and top element are not matching, simply push it. If both are matching, right now you can see X and Z are not matching, simply push it. Now stack dot length is greater than 0 and the stack top element and character both are matching. We just need to pop it. That's what. I think this is the only loop we need to do. And then we can do return stack dot join. And we can simply join it because without space. Let's see our answer. Let's see if we are missing anything. I don't think so. Let's check all the examples. This was very easy, I know. Let's see, submit our answer. Let's see. Okay, looks good, right? This was very easy code, right? Let me know in the chat if you guys stuck anywhere while understanding the code also. That's why I told you, right? This was the second question in our slides, which was not related to next greater element. Now all the question would be related to next greater element. Everyone okay with that? Arad, Deepak, Hariharan, Riyaz. Are we good with that? Can we move into the next question? Okay, so let's move into the next question, which is very interesting question. Very interesting. Okay, so now let's move into the next question. This question also exists in the lead code, so we can look from there only. Which is medium, actually complicated. It's little bit complicated. The medium one. Let me remove the code. Okay, guys. So let's read this question. So, guys, this is the one question I am telling you in your assignment. In your assignment, today's end of this class, there is one assignment. There is one question which is totally similar to this. You just need to do little bit extra there in your assignment. So that's why you understood this question, and then you try to do the same question in your assignment. Okay. So let's try to understand this question, and it's very interesting. So guys, what they're saying, we will be giving an array of integers. We need to find the sum of minimum V, where V ranges over ever contiguous sub-array of array. Every contiguous sub-array of array. Since the answer may be large, return the answer modulo 10 की power 9 plus 7. आंसर थोड़ा बड़ा हो सकता है, इसलिए सम करने के बाद so you can send the answer with the modulus of 10 की power 9 plus 7. Why the answer could be bigger? As you can see, the array length is 3 multiplied by 10 की power 4, and each element in that array could be 3 की power 33 multiplied by 10 की power 4. That much big number could be there. Okay, so let's understand. I know you guys have not understood the question till now, but let me first bring it here. Our next question. Okay, what is happening again? Something is happening again in my page. Okay, I can erase this, by the way. I think last time also happened, right? We closed it and opened it and then it worked. Let's see. We need to do this also. Okay, so let's take. Okay, for understanding, let's take a bigger array. I think I have bigger array in my book. 1 minute. Yeah, let's take this one for understanding this question. Or by the way, no. I think while we will try to solve it, at that time we'll take the understand. But let's first understand what is sub array here. I think, yeah, for that I think smaller one is fine. So before that, I already shared. Let me come back to this one. I already shared in LinkedIn the differences between sub array and subset, and there was one more thing. What was that? Subsequence. I remember you guys can check in the LinkedIn, but the difference was between the sub array and the subset. The difference between these two guys, in sub array, always element would be contiguous. Element would be in one order. Whatever order they are following, the element or the subsets of or the all the sub arrays of those elements will be in contiguous manner. And in subset, if you guys remember, always we have one empty, right? Always we have an empty array. But here, the sub array known as non-empty contiguous sub array, non-empty contiguous array. That's what we say. Now let me show you what's the difference here very quickly. So now guys, if you want to create sub array for this array, it will look like this. First would be 3, second would be 1, third would be 2. You can see how the order wise they are coming. Fourth would be 4, then 3 1, then 1 2, then 2 4, right? And then again we can start from like this: 3 1 2. Correct? 3 1 2. Next 1 2 4. 1 2 4. Next, is there anything else which is left? No, right? Let me count it out. I think there is one thing left. Or are we okay, guys? Here 3 1 2 we have taken, and we yeah, there is one final one. That's one. 3 1 2 4. That's why. Correct, guys. I think these four could be these could be the sub array. And guys, the important thing to notice here, they all are in the contiguous order, whatever order they are following. What I'm meaning, this it could not be like this 4 2 1. This could not be sub array of this array. This 4 2 1 could not be the part of this sub array. Could not be the sub array for this array. But in subset, it could be possible. It could be one of the subset of this array. Okay, guys. So that's the difference between sub array and subset. Understood, guys? Let me check in the problem also. Are we getting the 10 only? 1 2 3 4 5 6 7 8 and 10. Yeah, looks good. So 3 to 4, 3 1 2 4. Yeah, that one I was missing. Correct. 3 to 4. Oh, continuous. Yes, they would be contiguous. They would be contiguous. Neither it could be subset the 4 to 1. The 4 to 1, 4 to 1, I think it could be subset, right? Which one has empty value, subsequence or subarray? Subsequence. Subsequence will also not have empty value. Subset only will have the empty value. Subset will have only the. Let me open that one quickly. Let me open that one. I remember what I remember with the first view, that subset can only have the. See guys, there are three things: subsequence, subarray, and subsequence, subarray, and subset. Sub is subsequence and subset. Subsequence and subset. Subsequence and subset. They can have any order. They do not follow any order. The numbers could be anything. In subsequence and subset, they do not follow any order. The number could be 4 to 1 there. But the difference between these two is subset has empty one also. Subset has empty one also, but subsequence does not have empty one. That's the difference between subsequence and subset. Now subarray comes. Now subarray comes. Subarray does not have empty one, does not have empty one, and it follows order. It follows adjacent order. So that's what I remember. Let me quickly check it. I think we have it in LinkedIn, right? In the group. Let me open it very quickly. I posted it out there, right? Yeah, this one. You see here? So they have an array 1, 2, 3, 4. If the array is continuous sequence in array, so sub array would be 1, 2, 1, 2, 3. They do not have any empty one, and they are going to follow the order. In subsequence, need not to be contiguous but maintain orders. अच्छा देखो, need not to be contiguous but maintain order. अच्छा देखो यहाँ पे क्या है कि subsequence में एक चीज और है, same as subsequence except it has empty. अच्छा, okay. Okay guys, one more thing. Need not to be subcontiguous but they follow order. अब देखो 4 to 1 अभी भी नहीं हो सकता है. Sorry for that guys. 4 to 1 still could not be possible because that would not follow the order. 4 could not come before 2. 2 could not come before 1. So what they mean is there could be 1, 4 in the subsequence and subset. 1, 4 could be one of the part of that array, but in the sub array 1, 4 could not be. Sub array, no, because they should be contiguous. So after 1 only 2 has to come, after 2 only 4 has to come. That's the meaning of contiguous. And in subsequence and subset, they are saying they have to follow the order, and subsequent does not have empty one. That's what I already told you. Does not have the empty one. But subset can have the empty one also. Okay. So this is the link from where I have understood. So you guys already shared it. You guys can also check it. Okay. By the way, I have explained it. Let me explain it quickly again. Then we can move on. Okay. So guys, so first we have understood the difference between subarray, subsequence, and subset. In the subarray, I told you the subarray, they have very interesting properties, which is contiguous and non-empty and contiguous. You guys can see here is no, in this all the subarrays we do not have any non-empty arrays. All the arrays have one element. Again, they are following the contiguous. Contiguous means always after 1 the next adjacent element has to come. So you can see 1, 2, always 1, 2, 1, 2. Wherever you will see 1, everywhere 1, 2 is coming, or the simple 1 is coming. Correct? So that's what the subarray. But if you talk about the subsets and subsequence, so in subsequence they also follow order. Both follow orders, but they do not follow contiguous. The number could be, the subarray or subset could be non-contiguous. It means 1, 4 could come there, right? 3, 2 could come there, 3, 4 could come there. They could be like that, but they should follow the order. After whatever the order they have given in the input, Same order we have to follow. It should not be like 4 comma 3, because 4 comma 3, 4 could not come, like 3 could not come after 4. 3 could not come after 4. That's what you need to remember about the subset and subarray. And in the subset, we always, like, it's all subsequence, but it just have one extra empty one. One empty array also it considered in subset. That's the difference. I hope it clears to you guys now. Is it clear to everyone now? Can we move on now? Okay, great. Okay, so that's how we create it. So now let's understand how we will be solving this. How we will be solving this. Because I think if we want to do the brute force, so it would be first create all the, okay, we still have not understood the question. We still have not understood the question. So till now we only have created the sub arrays, right? So we can say we got 10 sub arrays, right? We got the 10 sub arrays. And now question is saying in all the sub arrays, you need to find out the minimum. In all the sub arrays, you need to find out the minimum, and then you need to add those minimum. If you, now let's come back to question again. So now you can understand sum of sub array minimums. It means in all the sub array, first find out the minimum, and then whatever minimum is coming, you just need to add those minimum, and then you have to give the final result. So now let's see. From the first sub array, it's 3. I'm just adding them now. From this array, it's 1. From this array, it's 2. From this array, it's 4. From this array, it's 1. From this array, it's 1. From this array, it's 2. From this array, it's 1. From this array, it's again 1. From this array, it's again 1. Right? So if we add them, so let me know. 3 plus 1, 4, 6, 10, 11, 12, 14, 15, 16, 17. Answer should be 17 here. So let's check it. Yes, answer is 17. Everyone understood? Riyaz is saying no. About what, Riyaz? Which part you didn't understood? Is it the subsequence and subarray part or the question part? Quickly respond, Riyaz, so we can move further. On link lead code, question number is 907. 907. Okay, so Riyaz is not answering, so let's move in. Let's move further. So we'll see his question. Okay, so guys, so that was our question, guys. I think it's everyone has understood, right? So let's now try to solve it. And guys, now bring all those next greater and next small as in your cache memory. Bring all those things in your cache memory. Okay, so let's start understanding this. So I will take a little bit bigger example to understand that. Okay, which I have taken in my copy. So let me take that one also. So 2, 9, 7, 8, 3, 4, 6, 1. Okay, this was the array, like little bit bigger one. Okay, right, guys? So this is the array which we are going to talk about today. 1 minute, guys. Okay, that's fine. Okay, so let's write it out there indexes also very quickly, or let's wait, or no problem. Let's write it. Let's write the indexes also. 0, 1, 2, 3, 4, 5, 6, 7. Correct. So now let's find out. Let's pick any one element from there. Let's pick any one element from there, like 3. I am picking 3. Correct. And now I am guessing that in how many sub arrays, everyone listen, in how many sub arrays this number could be minimum. Does it make sense why I am looking this? In how many sub arrays this number 3 could be minimum? Does it make sense why I am looking for this? Because at the end, from each array, we need to find out the minimum. From each array, we need to find out the minimum. तो हम ये पता करते हैं कि ये नंबर 3 कहां पर मिनिमम आ सकता है, कहां पर मिनिमम आ सकता है. So let's look into that, guys. If we talk about the nearest element to this, so see, if we take this two set, 3 will be minimum, correct? If we take these two elements only, 3 will be minimum, right? If we take these 3, again 3 will be minimum, right guys? If we take these 4, again 3 will be minimum. If we take these 5, will 3 will be minimum now? Will 3 will be minimum if I am taking these 5? No, right? Now 2 will be minimum. Sometimes I miss, like you guys should be able to speak. So I should not come back here. Okay, so yeah, so now you guys can see here, now 3 cannot be minimum, right? Because now 2 is the new who would be the minimum. Okay, understood. 2 would be the minimum. Okay, so let's look into the right side now. Till now we were looking into the left side. Let's look into the right side. So 3, 4. 3 could be the minimum, right? 3, 6. 3 could be the minimum. What about 3, 1? Will 3 will be the minimum? No, right? 1 would be the minimum. So can you guys now use your cache memory? And we have tried four solution. Can you guys tell me which one logic which we are trying to apply here? Which logic which we are trying to apply here for any of these stack elements? Sorry, for any of these arrays element, which logic? What are we are checking here? 3 is minimum until left, right, lesser element. Correct. Find nearest minimum on both sides. Totally right. Next is smaller. Yes. Next is smaller or previous is smaller. Correct. That's what you can see. For 3, 2 is the previous is smaller. For 3, 1 is the next is smaller. That's what guys we need to look for. Agree guys? Everyone agree with that? We need to find the left nearest and right nearest. Sorry. Yeah. We have to look for left smallest, left nearest smallest, and right nearest smallest. Everyone agrees? Riyaz, Arad, Hariharan. Left nearest smaller and right nearest smaller. Sarad, Arad, Riyaz. Everyone. So that's what guys we are going to do it for each of arrays element. Okay. Let's wait. Let's first check for 3. Let's first check for 3 only. So for 3, let's take first the right nearest smallest. Anything you want to write it, or right smallest anything. Let's take a small one. Why to like बढ़ाना इसको इतना बड़ा क्यों करना? Right smallest element, RSE, right smallest element, and then left smallest element. Okay, let's take for 3, and we will take this time indexes, guys. We will take this time indexes. That's why from the last class I am just focusing on the indexes part. Okay, let's find out the indexes. So the for 3, the the left right one, sorry, yeah, right one, it's 7. Correct. For 3 it's 7, and for the left side it's 0. Am I writing the correct indexes, guys? Am I writing the correct indexes? We are writing the indexes right now. We are writing the correct indexes. Okay, we are writing the correct indexes. Let's see how many. Now what we need to find out, guys, that we have finded out these things, right? And with this actually, okay, 1 minute, guys. We'll come back onto this, or should I try this one only? Yeah, let's try this one only. I was thinking to take a small example to explain my next thing, but let's try to understand this one only. Okay, so guys, and let's write their indexes also on the top. What is the index of this element? Which is 4. Did you guys can understand all these 3 things? index of that element, write smallest index for that element. Let me correct this one, not element, this is index, right? Write smallest element index, yeah, element index, and let left smallest element index. Okay, everyone understood these numbers? 470, everyone understood? 470. Okay, now what we need to do, we need to find out these things, like how many combination 3 could make. So let's see how many combination it could make. So what we need to do, we need to find out how many numbers it has, only that many combination which it can make, how many numbers it has the right side and how many numbers he has on the left side, and then we will simply multiply them. So let's try to find it out. So let's see. That's why I was thinking to take a smaller example. With that, you guys can understand better. Wait, let's take a smaller example. 3, 1, 2, and 4. Let's take this one only. Just to understand next logic, guys. So you tell me, for the 1, what is the next smallest element? For 1, what is the next smallest element? And let's write their indexes also. 0, 1, 2, 3. So for 1, the next smallest element is the outside. So this would be 4, right? Right, smallest element index. It would be 4 for 1, right? And the greater one, like the left side, it would be -1. Right, guys? It would make little bit difficult, guys. 1 minute, 1 minute. This is also this will also confuse you. 1 minute. Let's take for 2. I think, yeah, let's take for 2. It will stop here and it will go here. Correct. Let's take the 2 here and 1 minute. Let's take 0 also this side. I'm just trying to make a, like, I will come back to all the scenarios, but let's start with one by one all scenarios. Okay. Yeah. So let's take 5 indexes. 2 and 1 minute. 1 minute, guys. Let me just create a nice example so we can understand easily those things, right? And let's take 5 here also. Yeah, now it will make good example. Yeah, the one thing which I want to explain here: 0, 1, 2, 3, 4, 5. Now let's take for 2. Correct? Index is 3, right? And now the right smallest element index. What would be for 2? It would be 5. Right, guys? It would be 5. And for the left side, it would be 1. Agree, guys? So let's see how many combination 2 can make. How many combination 2 can make? So first is 2 also. 2 will make its own. 2 will make its own. Right? From here to here only it can make, right? From here to here. Now let's see 5 comma 2. This could be one combination. 5 2 comma 4. Here 2 will be smaller, right? What else we are having here? Yeah, 2 comma 4. 2 could be the minimum here. So is there any more combination 2 can make? I think total number of combination it could make 4. Agree, guys? The 4 combination it could make. If we check in this example, for 2 only, it can only make 4 combination. You can see, because this is the smallest one. अगर हमने 1 लिया तो 1 smaller होगा, अगर हमने लिया तो 0 smaller होगा. So wherever many places 2 could be the smaller, only 4 places. Right, guys? 2, 5 comma 2, 5 comma 2 comma 4, 2 comma 4. Did you understood this part? How the 2 could be how 2 could be smaller for 4 places? How 2 could be minimum for 4 places in this example? Everyone understood? Everyone understood? Yes, yes, click it. We'll do that. Everyone understood this thing? Okay, repeat. Riaz. So Riaz, you see this thing? Three comma one, 3 comma 5 comma 1. That was a okay. No. 3 comma 1 comma 5, for example, was 3 comma 1 comma 5. So we are looking for 2. How many combination 2 can make? Where 2 will be smaller. Correct? So अब हमें क्या करना पड़ेगा? देखो एक ये combination है जिसमें 2 smaller हो सकता है. So 2 could be smaller till here. And on the left right side 2 could be smaller till 4, because अगर इसके आगे गए 0 लिया हमने तो 0 would be smaller. That's why 2 would be smaller between these boundaries only. And now when we got 3 numbers here, 5 to 4, so now we to identify how many combination it will make. So you can see 2 would be making first self sub array, then it will be make one combination with 5 comma 2, then it will make another combination with 5 2 comma 4, then it will make another combination with 2 comma 4. That these are only 4 combinations which it would make. Understood? Understood? Hariharan, I am just looking for 2. I am just looking for 2. How many places 2 could be the minimum? In the 5 would be the minimum. Understood, Hariharan? I am just looking for 2 right now. Okay. So now let's try to calculate how can we get this 4 with these values, with these indexes, left, right indexes. How can we get these 4? That's what we are going to look, guys, here. So now let's find it out. These are the correct values, right? For the right smaller index is 0, okay, which is 5, okay, and the left smaller one is 1, correct? So what we need to do here, guys, what we need to do here, first we need to subtract 5 minus 3. So we will get the right side element. From the right side index, we'll subtract the element index. So we'll get these elements. So you can see 5 minus 3, if we'll do right side index minus original index, which will be 5 minus 3, which will give us 2, right? And then from here again we need to do original index minus left index. Always we are subtracting from right side to left side. You can see we have subtracted 5 minus 3 again from the original index minus LSC, left side index. So we'll get left side element, which would be again 2. So 3 minus 1 would be 2. And then we will multiply these two numbers and we will get the 4. You can see once we do right side index minus original index, we'll get all the elements which are going to be right side. You can see here 2 comma 4. These are there would be 2 elements which are going to make the combinations, right? Again for the left side, that's what we did again, the original index minus left side index, and then we got 2 here. Understood, guys? This is the logic actually which we need to follow for each of the element. Okay, so see, okay, so as you can understand, for 2, the total combination could be 4, and somehow we need to reach to this answer. How many combination we can make? Correct. So what we did here, from the right side index, we calculated all the elements. Like how many element could come between that? How many element could come between that, including the original one also? Because we are looking for it now. So how many element could come including the 2 also, including the 2 also. So that's why what we did, 5 minus 3, it will give us 2. So you can see 2 and 4, only these 2 elements are coming between them, between the original index and the right smaller index. Same goes for left also, because 1 was there, which was the smaller element, so the index was 1. So how can we find it out with the differences of indexes? We can just subtract original index minus left side index. We will get the between elements. We'll always get the between elements. You can see 3 minus 1 is equal to 2, and then we multiply it, because this right side indexes and left side indexes, they will be combined. They will be combined, will create these much combination, which was 4. Let's look for any other number. Let's look for here, guys. Let's look for here in this form, in this scenario. So for the 3, the index was 4, and then for the right side index was 7, correct, and left side index was 0. So now do the same thing. First, right side index minus original index, which would be 7 minus 4 is equal to 3. Then do the left original index minus left side index. Always, because we are subtracting, right? We are subtracting. So from the bigger one, we will subtract the lower one. So now 4 minus 1 is equal to 3. So in this case, 9 combination 3 will make. And let's check it. 9 combinations are coming or not. So let's start from starting. So first thing, 9, 7, 8, 3. This is the first combination. correct? Now 978346, second combination. 97834, third combination. Till now we did 3 4. Okay, let's see one more combination where everywhere 3 would be smaller. You can check. Now let's see. I think we have already covered all the 9 scenario. Let's start with 7 now. 78346, right? Now 7834. Okay, 783. Okay, now we have completed all the 7 scenario. Now let's look for 8. 8346, right? Now let's look for 834, right? And now the next would be 3 comma 4. And I think there would be one more, I believe. 3 comma 4 comma 6, right? So how many combinations are coming? 1 2 3 4 5 6 7 8 9 10 are coming. One is missed, one is extra here. Are we missing anything here? Let's check here first. So for 3, the index is 4, okay. And the lower one we got the 7, correct. For the greater one we got 0. Oh, okay. What is this? This is 0, right? 1 minute, guys. I missed it. I have taken 1 here. I don't know. In the chat, I know you guys were telling it. Okay, so 7 minus 4 is equal to 3. And 4 minus 0 is equal to 4. It should be 12. I think 2 more combinations will come here. What are those combinations? Oh, 3 would be also 1. Okay, 3 would be 1. And what else we are missing? Oh, 8 comma 3. We are missing 8 comma 3. Okay, anything else we are missing? No, right? Yeah, I think we have proof from both sides. We have proof from both sides. Yeah, actually, sorry guys, sorry Ekta for that. Yeah. Yes. Why not 4? Yes, I missed that one. Sorry for that. 3 comma 6, yeah. Nilu, no, Nilu, they are not contiguous. 3 comma 6. No, yeah, 3 comma 6 will not be there. They are not contiguous, right? The sub-array condition, Nilu. Sub-array condition is the element should be contiguous. If we are looking for subset, if we are looking for subset or subsequence, 3 comma 6 could be there. Everyone understood? Everyone understood this part? How we are getting the answer here? That's what we need to do in the questions also, guys. We need to find it out all the all the indexes here. So let's try that. Let's now take the smaller one, this one, 3124. We'll get the answer here quickly. 3124. Otherwise, this will be bigger, the answer will also be bigger. Right? So first, guys, you guys tell me the indexes. So indexes are very easily 0, 1, 2, 3. And if there is no element, we'll take the 4 here. And if there is no element on the side, we'll take the -1. These are the extra indexes. Okay. Now you guys tell me, write smaller element index. You guys tell me. You guys write it in the chat. I will looking for write smaller element index for 3124. You guys write it in the chat. 3124. Everyone, 3124. You guys write the right smallest element index. -1 when you are trying to find something on the left side, but you didn't find any smaller element. So you will take the -1. Okay, Ariran? If you didn't find any of the smaller element, you need to find you will find it out you will put it there -1. Yeah, for each element. Yeah, for each element. Please tell me right side smaller element index for the each element. Everyone. So Ekta has given answer as a 1444. What about others? Likit has given -1, -1, -2. No. For 3, -1, comma 1. Yeah, right side would be length. Guys, for right side it would be length. Likit, yours are not correct. Right side we are asking. Right side. Vishal, for you also. I'm not sure you have given left or right both. It looks like you are giving right, left or right both. Hariharan, no, that's not correct. Yeah, I understood your Vishal. That's right. Understood your. Yeah, yours one is correct. I didn't say yours one is wrong. Yours one is correct. Arad, yours one is wrong. Minus one could not be there. In minus one could not be in any condition. We are looking for right side. And if there is no any element, we are saying we will keep the 4 there. If we do not find any lower element, we will put the 4 there. Yes, Likit. Now it's yours correct. 4 4 1 2. No, no, Arad. Still yours is wrong. Try to look for. Yes, Arad. Yours is correct. Hey, do not copy paste. Do not copy paste. Just try to think about it. Right side lowest element. Right side lowest element. Ah, okay, okay. Understood, understood. Arad, what would be the right smallest element for 3? What would be the right side smallest for right side first smallest element for 3? Right side first smallest element for 3. Yes. So answer would be 1. What about 1? The next element. What would be the right side first smallest element for 1? You tell me, Arad. What would be the right 4? Yes. What about 2? What about 2? Right side smallest element. Yes, again. Yeah, it's index 1. You see, we are putting indexes only. Hariharan, we are putting indexes only. Now you guys tell me left smallest element index. For each element, left smallest element index. And this time, wherever you didn't find, you will put -1. If you not find, you will put -1. You guys tell me in the chat. Left smallest element index. What about others? Deepak, Riaz, Sharad. Sharad, I think Sharad is providing answer. Parag has given, okay, -1, -1, 2. Let me check. For 3, it would be -1. For 1, it will also be -1. For 2, it would be 1. For 4, it would be 2. Yes, -1, -1. Neelu, yours is wrong. Arad, yours is correct. Parag is correct. And Ekta, yours is correct. Yes, we have more good questions, but those are related to this one only. Suraj, yours is also correct, not correct. Deepak, yours is also wrong. So guys, this thing first you have to understand. Otherwise, I will go and explain the logic again. But if you are not able to solve these things, this would not be good. Okay, last element will not be 1. For 4, 2 is the smallest element. 2 is the first smallest element. So -1, -1, 1 comma 2. This would be the answer. For 4, left side first smallest element is 2. So 2 is the answer. Understood, Deepak and Hariharan? And Neelu, you guys have pasted the wrong one? Yeah, it will be my son. Now what we need to do? The first thing, right side element index minus original index. Again, then what we need to do? Left side element index, original index minus left side element index. Correct? So let's calculate it for each element. So right side index is 1 and original index is 0. Right side index is 1, original index is 0. So 1 minus 0 will get 1. Correct? 1 minus 0. 4 minus 1 will get 3. 4 minus 2 will get 2. 4 minus 3 will get 1. Okay? Now let's calculate this one. Original index minus this one. Original index is 0. Left side index is -1. We'll add it. 0 minus 1. It will become +1. Now do it here. Original index is 1 minus 1. We will add it. It will become 2. 2 minus 1, it will become 1. 3 minus it will become 1. Correct, guys? And now we need to multiply these two. Now we need to multiply these two. So we need to multiply these two. I'm just writing it, multiply these two. So we'll get 1, 6, 2, 1. And these would be, and our original array looks like this: 3, 1, 2, 4. And you can see 3 will come in one time, 1 will come 6 times, 2 will come 2 times, 4 will come 1 time. So just multiply these numbers directly now. 3 multiply 1, because 3 will come 1 time, plus 6 multiply 1, 2 multiply by 2, plus 4 multiply by 1. You will see 3 plus 6 plus 4 plus 4. Again, we got the 17. That's how we are going to get the answer, guys. So first we subtracted it out. After subtracting, we are multiplying these two. Once we multiply these two, we got how many times this number will come as a minimum. And once we got how many times these numbers are coming, we are just simply multiplying them. And then we got the answer. This is the sum of sub-array minimums. Hope everyone understood. So the first smalls, then. So first you have to subtract the right side minus original index, then original index minus left side. That's what we did here, right? Right side index minus original index minus left side index. Then we need to multiply. Okay, so the one doubt, why we took 4 in right and minus 1 in left? Because, Arad, we are looking into the left side. Our array, our indexes looks like this, right? 0, 1, 2, 3, 4, 6, 7. So we are considering the before 0th index as a minus 1. And after that, when our array is ending, what will be the next index? It would be 4. That's why we are considering the next index. When we are looking for right side, we are looking the last index, like after the last index, which would be 4. And before the first index, it would be minus 1. Like before the first index, and then after the next index. So can you explain the OG minus LSI once? I have a doubt the values seem to be a bit different to me. Okay, OG minus LSI. Okay, let's see. So original index is 0 and it is minus 1. So 0 minus minus 1. It will give us 0 plus 1, which would be 1. Okay, let's look for second index, which is 1 minus minus 1. Will give us 1 plus 1 is equal to 2, right? Let's look for second index, 2 minus 1, which will give us simple 1. That's what is here. Let's look for this one. 3 minus 2 will give us 1, which is here, right? Okay, then we are assuming our next lecture will be fourth index. Yeah, because there is nothing in array, so we'll just take the next index. Okay, guys. Okay, just one more thing here in the same question. Just one more thing. I don't know you guys have seen that problem or not, but let me 1 minute. There is one more catch in this question. Yeah, this question: 71, 55, 82, 55. When we are getting duplicate element, guys, when we are getting duplicate element, this is another, actually in the same question, this is another scenario when we are getting duplicate element. Can anyone tell me what will happen in a duplicate element? There is one thing which we need to do in the duplicate element. Just think about it. So in the case of duplicate element, guys, we will take only from one side. अदरवाइज या तो लेफ्ट साइड से ले लो या फिर राइट साइड से ले लो, एक ही बार हम कंसीडर करेंगे उसको. करेक्ट. अभी क्या कर रहे हैं हम अभी क्या कर रहे हैं, we have to take it only one time, from one time. This 55 we have to take it only from one time, one side. Even if you are taking it in the lower side, So take it in the, sorry, if you are taking it in the left side, so just consider on the left side. It has a smaller one. Correct? So let's see. Let me solve it for you guys. 0, 1, 2, 3. Okay. So let's first calculate the right side index. And let's consider in the right side index, I am taking it as a smaller one. I am taking it as a smaller one. So I will not go ahead of it. Okay. So let's see. So 55, 82 and 55. So we will stop it here because I'm considering this as a smaller one. Right. So it would be 3 for the 55. For 71 index would be 1 because 71 the right smallest is 55. For 82 it would be 3 and for 55 it would be 4. Correct. Now while calculating the left side index, now we will not calculate the 55 is as a smaller one. We will pass it. So now for 55 there is no smaller element. For 55 there is no smaller element. So we will simply put -1 here. For this 55 also -1. For this 82 1 would be the smaller. For 71 also -1. I hope you guys have understood this, what I'm saying. Because if you want to calculate the sub array of this for this 55, let's just talk about this 55. So how many combinations it will create? Because we are stopping it here, right? We are saying we are stopping it here. For this 55, we are stopping it here. We are not considering this 55 there. Correct? So let's see for this 55 only. So 71, 55, 82. This is one combination for 55. The second would be 71, 55. Correct? What else? 55, 82. Right? And then 55 itself. So 4 combinations are there for 55. Correct, guys? If we are considering these 3 elements only, we are not considering this as the smallest element. So we are considering this as the smallest element. Right? Because now we have duplicate element, right? In the duplicate element, we have to take 55 only once. Correct? So that's why you can see in this combination, I have only taken once 55. Correct? So let's find it out answer for this. So the 3, and we are taking the for this the smaller one is -1 this side, right? So let's calculate. What is the index? So right side index minus original index, which will give us 3 minus 1 will give us 2. Original index minus left side index, which will also give us 1 minus -1, which will give us 2, which will give us 4. So that's why 4 is the combination here, right? Now let's take, this time we have not included this 55. Now let's talk about this for 55. Now when I'm saying this is the 55, I'm not considering this 55 as a smaller. I'm not considering, when I'm talking about this 55, I'm not considering this 55 as smaller. I'm including this one. I am including this one. So let's talk about this one now. I got first check from here. So again, right side index minus original index. Right side index minus original index. So 4 minus 3, it will give us 1, and left side index, original index minus left side index, which will give us 3 minus -1 is equal to 4. 4. And here we will also get the 5, 4. So you guys can see now, if we are considering this one, so let's see how many combination will this one. So first thing, the whole 75, 55, 82, 55. This is the first combination, because now we are not considering this 55 as smaller. We are considering this 55 as smaller. Okay, this is the first combination. The second combination would be in the smaller one, 55, 82, 55, right? And then 82, 55, and then self 55. You can see the same one, this one. So you can see nothing is repeating, and 255 is coming here, because we have included one place 55, and in another, while we are considering this 55, we are not considering this one. We are not considering this as we are not considering this element. So that's why you can see 2 combination for those 55. A total 55 multiplied by 8. You can see because that would be because you can see this one is also coming 4 times, this one is also coming 4 times. So at the end, in the answer, 55 multiplied by 8 will happen here. Understood, guys? We have to just consider, see, this is not a problem, Vishal, because now you will be getting difficulty, because in one place you need to consider 55 as a smaller. In one place you need to consider, because while you're writing the loop, while you're writing the while loop for RSC, let's consider for while you're writing the RSC function, at that time you have to stop for equal condition. You have to stop for equal condition, or you have to insert. You have to insert the index when the current element, when the stack current element and your 55 is matching. You have to stop there. That's what the problem here. Otherwise, in simple form, in other problems, we will skip it. In some other problems, you will skip the duplicate elements. You will just go for the last element. You can see, right? For the right side element, I stopped at the 3. 55 is still not minimum, but I stopped at 3. Understood? This is not looking like weird to you. Why I stopped at 3? That's why this is little bit different. In other scenarios, if this is not the case for 55, we will be skipping it. We will be going on to the 4, because 55 less than 55, 55 less than 55, it will give us false. But we are not saying it is a false. We are stopping it here. We are putting equal here. So whenever we are getting 55 is equal to 55, we will not go into the loop for popping it out. Understood, Vishal? Yeah, everyone understood? So I think these are only the corner case here. Otherwise, everything is good. Okay. So we'll consider equal scenario only in either case, LSI or yes, in any one of the case you have to consider. Let me show you code very quickly. I have the code for this, by the way, if you guys want to see that. Before that, you see, I failed on, just because of this duplicate condition, I failed it many times. Just because of this duplicate condition, I failed my case many times. So that's why actually this case was very important. So I put it into the right side only. I can open it there, right? No. You see, on the next left element, I'm just looking for greater element. I'm just looking for greater element. And you can see, while pushing it out, I'm also checking for equal condition. If you remember, in else if condition, I never look for equal condition. Whenever we are getting lesser element, only we need to push those into our answer. But here you can see in the next left element, I'm also looking for equal. That's the difference here. And code is very similar. So we started we passed our array to previous left element, then we passed our array to next left element. Correct? And then we started our stack as 0, answer as -1. Because we have already seen this code in our previous class. Already we have seen this code. So nothing new here. But just the one thing which was new here, which was this one, these two. We are only looking for, while we are popping it out, we are only looking for greater element. Correct? Otherwise, you can see in the left scenario, if we find it out equal, we are simply popping it out. We are simply popping it out. But here, we are not popping it out. We are going for the less than equal also. I will paste this code. You guys can check it out. And answer.reverse, as I told you, whenever we are looking for next side, right side, you always have to answer.reverse. I think this code you're already aware of. See, one condition which I put it out. Earlier, if you guys remember, I first check for if stack.length is equal to 0, then push the array element in answer and there element. But till here, I did it outside only. Stack is equal to n-1 because always we know that, right? Last element would be 4, first element will be -1. You can see first element when we are talking about left side, first index will always be 0, first answer would always be -1. In the same case for right side, first index would always be like the last index 3, and answer would be 4 for that scenario. So that's why I started loop little bit further. You can see I started loop from 1, not from 0. So yeah, you guys can later look into that. And then after calculating the array, PLE and next element, the same logic, array I multiply by, first I subtracted it, you can see I minus previous element, I minus original index minus previous element, next element minus index, next element minus original index. First I multiplied these two, then I multiplied with array, and after that I sum it. And then if you remember this condition mod m, because this sum could be lot bigger, so that's why they are saying you need to at the end just sum your whatever sum you are getting, you just mod it with 10 to the power 9 plus 7. If you guys remember in the top of the question, they were mentioning, right, since the answer may be large, return the answer modulo 10 to the power 9 plus 7. That's what at the end I was doing. Okay, I think I have already this code in the, yeah, I already had this code here, so you guys will get it here, get it into the you guys will get it into the GitHub. Okay, so guys, similar question you guys have in the slide, similar question, and that question is little bit you need to think in the same question. Let me show you that question also, which was I think sum of sub array ranges. Yeah, I will give you this question because you guys have already seen everything code and everything of that. So try to solve this question. It's very similar, but just you need to find out some extra thing here. I will paste it in the chat. Okay, similar question, very similar question. And this is on your assignments also. Okay, guys, can we move into the next question now? Can we move into the next question, guys? Oh, you guys want break? Okay, sure, sure. So let's go for break, guys. And right now it's 9:25. So we all can be back at 9:40. Okay. We all can be back at 9:40. In meanwhile, I already pushed my changes in the GitHub stack branch. So you guys can see the code there. Okay. So let's come back at 9:40. Is everyone back? Okay. So for guys, first let's understand all the logic, because everything is very related here. Wherever I will see there is any minor cases are there, I will just show you the code there also. Okay. So yeah, so if everyone is back, so let's jump into our next question. 1 minute. Let me just turn off the charger. Yeah. So Arad is saying, can you explain the code again? So Arad, so first we need to calculate what? First we need to calculate the right smallest element. Understood? Yes, right smallest element. Then we need to calculate the left smallest element. Correct? Now we got two arrays. For our original array, we got two arrays. Correct? After that, we need to put our logic, which was right right side index minus original index multiply original index minus left side index. This logic which we have discussed here. Right side index minus original index, left side index minus result, and then we need to multiply these two numbers. And once we are multiplying each of the, because we are doing the iterations, so once we are multiplying, we just need to add it. Okay, same thing is happening in code also. So you can see from here we are starting. First we calculated previous left element, then we calculated next left element. Once we calculated, we started our loop. Now you can see in the one loop, we are just checking. First we are checking I minus PLE, which is original index minus left index, multiply by next index minus original index. And once we multiplied this thing, once we subtracted it and multiplied it, then we are multiplying with the original index, original array element. Because once we got that 3 is coming 4 times, it means 3 multiply 4. And then we are at the end, we are adding everything. Then we are doing modem. And there was one duplicate scenario where I told you to do not take that element, because we need to take that element and only at one place. So that's why we are doing that greater here. And less than equal in the right scenario, because I am taking that element at the next side. That's what I showed you in the here also, because you can see in the right small element we are taking 55 as the smallest one. That's why we are considering it's the third index. That logic is here. Okay, you can like later see this thing first, but you, as you already implemented next greatest element, next smallest element, you do not need to look into the code now. You have to implement by your own. Okay, Raj? Understood? Yeah. So let's move into the next question. Okay. Yeah, stock span problem. Anyone tried to solve it? I've already shared this problem in the LinkedIn also. Let me search it. Stock span problem. Okay, so we'll not try to implement this thing, because you can see they are using older JavaScript and they are passing input in some other way. Okay, but yeah, let's understand the question, what they are saying. So they are saying we need to design an algorithm that collects daily price quotes for some stock and returns the span of that stock price for the current day. Okay, so matlab, they will provide one array to us where we are going to see the daily prices for that stock. They will be giving one stock to us and they will be giving us 7-day price for that stock. Okay, and then what we need to tell, let's see, the span of stock which we need to return is defined as the maximum number of consecutive days. Guys, maximum number of consecutive days is starting from today, going backward. Starting from today, going backward, for which the stock price was less than or equal. I think they have given everything in this condition. You do not need to think. Like, see, in the previous question, when we were talking about the sub array minimum, you need to little bit think about. But here, they are telling you everything. They are saying you need to find out the number which is less than or equal to today's price. Understood? Let's write this array. Let's write this array. Our array is 100, 80, 60, 70, 60, 75, and 85. Okay, guys, this is the stock price. Any one stock. This was day one. This was day 2, 3, 4, 5, 6, 7. Like that, they have the day. They have given provided us 7-day data for one stock, and they are saying what they are saying. We need to return the span of that stock price for the current day. And how we are going to calculate that span? They are saying the span of stock price today is defined as the maximum number of consecutive days starting from today and going backward, for which the stock price was less than or equal to today's price. Can anyone can tell me what we are trying to look here? While understanding this problem, can anyone tell me what we are trying to look here? Where to find the previous stack codes in your repo? Not the PayPal one, github.com. In meanwhile, just think about it. They are saying we need to count. See, क्या कह रहे हैं वो लोग? वो कह रहे हैं we need from any current day, कोई भी किसी भी day में, like 5th day, we need to find, we have to go backward and we need to find out all the consecutive day when the price was lower or equal. You can read again 1 minute. Likit, you can read the question again. They're saying you have to go backward starting for today and going backward, for which the stock price was less than or equal to today's price. तुम्हें वो सारे day count करने हैं. You have to count all of those day where the price from today is less than or equal. Just think about it. And meanwhile, let me give code to Likhit. So Likhit, you have to go to stack branch. Which branch? Stack. And here you can go for stack, and here we can look for sub-array minimum. This is the code here. Got it? Got it? So explain question again. Question get it. Acha, question get it. Okay. Fine, LG. Okay. No elements before or previous greatest. No elements before or previous greatest element. No elements before of previous greatest element. Acha. Yes, Likit. Yes. Sir, please explain question again. अच्छा ठीक है, पहले क्वेश्चन एक्सप्लेन करते हैं एक बार और. देखो हरिहरन, we got one stock, okay, or we have the price for that stock for 7 days. Like 21st को ये प्राइस था, 22 को ये था, 23 this, 24 this one, 25 this one, 26, 27. Okay, they are asking choose any of the day in this array. Choose any of the day, like 24. You have to count all the previous days. You have to count all the previous days when the price was lower or equal. When the price was lower or equal, you need to find that number of count. We have to give that number of days. You have to give that number of those days where the today's price, from the today's price, all the price was lesser or equal. Understood, Hariharan, now? Okay. So now, so you can see they are saying us to find out all the lower element to the left side till we got a greater element. Till we got the, see, let's try to understand. Let's take 75. So we need to find all the lesser element. That's what they are saying, right? Go backward and find out. Let's read one more time the question. They're saying, yeah, go backward from today for which the stock price was less than or equal. So let's see. For 75, the price is lesser, okay. Lesser, yes. 60, yes. Till here. Till here we can go and we can say the days are 4. Correct? For the 75, because we have to take this one also. That's what they're saying, equal also. So that's why for 75, this will be 4 days where the price was consecutive 4 days backward, it was low. Let's look for 85. 75, 60, 70, 60, 80. It was this one, right? So how many days? 1, 2, 3, 4, 5, 6. Correct? 1, 2, 3, 4, 5, 6. So answer would be 6 here. Look for 60. You guys tell me for 60. You guys tell me for 60. How many days? For 60, how many days? Wrong, Likhit. Wrong, Suraj. What do you need to find out? Just think about it. क्या find out करना है? What we need to find out? Oh, okay, yeah. Yes, yes, yes. No, no, no. Actually, yes, yes, yes. I was saying this. Okay, okay, okay. Yeah, yeah, yeah. For 60, yes, that's right, that's right. Sorry, sorry, guys. It would be one only. Sorry, I missed it. Yeah. Yours one is correct. Likit, yours is incorrect. Suraj, yours is also correct. Hari Haran was wrong. Sorry. For Hari Haran, it's wrong. Yeah. I was just looking for 80 because I was looking this answer. I'm counting from here. So that's why actually I got confused. It was 3. So yeah, I think this would be this because we before that there is no previous smaller, right? We got 70. So for this it would be 1 only. Correct. Yeah. Now look for 70. So now for 70 it would be 2, right? It would be 2. For 60 again it's 1. For 80 it's again 1. For 100 it again 1. Because there is no lower element before them. Let's compare it with the answer. Are we doing the correct? Let's see. 1112146. 1112146. Understood, guy? Understood, guys? Why one didn't get where? For both 60s. For which Vishal you're saying there are 260s? Yes, there are 260s. That's right. So look for first this 60. इससे पहले छोटा क्या है? First छोटा. इससे पहले तो बड़ा ही आ गया 70. So that's why we'll consider this one only. That's why we'll consider only this one. The question was find out all the lesser one or equal one. All the lesser one or the equal one. Equal one, equal. 60 is equal also. So that's why it will be 1. Understood, विशाल? क्योंकि 60 के लिए हमें बराबर क्या उसने क्वेश्चन पूछा था कि हमें लेफ्ट साइड जाना है और जो भी इक्वल हैं और जो छोटे हैं उनको देखना है. तो आज का प्राइस तो इक्वल ही है उसके लिए. So that's why it would be 1. Understood, Vishal? नो इक्वल और नो नो नहीं लेफ्ट में नहीं, उस आइटम को भी इंक्लूड करना है. वी हैव टू इंक्लूड दैट एलिमेंट आल्सो. वी हैव टू स्टार्ट फ्रॉम देयर. यू सी इन द क्वेश्चन वी हैव टू स्टार्ट फ्रॉम देयर, स्टार्टिंग फ्रॉम टुडे. and then going backward. So starting from today, so today's value is already equal, right? Understood, Vishal? Today's value is also equal, right? Yeah, today is inclusive. Okay. Now let's look for fifth index 60. Oh, that's what I was explaining, right, sir? 60. Because we have to look for today also. We have to start from today and then start looking from today to backside. So first we have to check all element on left, and if pointer is out of point, we should return 1. Yes, we can say that also. But if we can include that one also, that's fine. Let's check. Let's check about how to solve it. But let me first go back to Sarad. Sarad, did you understood for the fifth index? Sarad? Because we have to include we have to start from today, and we need to look two things, smaller or equal. So today's will be equal. 60 आज का प्राइस है तो 60 बराबर ही रहेगा. So if we include today's first all element and add at the same index, yes, that could be one way. Yes, but I didn't get the answer 1 for index 5. Yeah, that's what I'm explaining. So according to you, what should be the answer for fifth index? Sharad, according to you, what should be the answer for fifth index? 2. Why? Why it should be 2? Just look into this array here. Why it should be 2? Then I think it will be clear. Just look into this fifth index and think about the question. You need to look for the previous lowest, previous smallest, or equal. You need to look two things, right? Same element in index 3 element. But उससे पहले तो 4 आ गया ना. उससे पहले fourth element. But we were always looking for first one, right? We were always looking for first one. Not in the whole array. You remember we are solving questions from the starting. Yeah, consecutive, correct. From the starting we are looking for only first one. Understood, Sarath? No problem, no problem. It happens, it happens. It happens with me also. That's fine. Okay, so let's try to solve it. So as I think you guys have already guessed the answer, that we need to find out the previous greater element. We need to find out the previous greater element. There we will stop. There only we will stop. Correct? Because after that element, all element would be smaller. If I look for 75, where we have to stop? For 75, we have to stop at 80. Right? We have to stop at 80. I know you guys already has given this answer, just reiterating it. So for each element, we have to find out the previous greater element. Wherever that previous greater element, we will stop there. Okay, so let's find it out. Okay, let's find it out. So let's for the previous, so for 100, it would be -1 because there is no greater element. So it would be -1. Again, we are taking the indexes. For 80, it would be 100. So the previous, let me write the indexes also. 0, 1, 2, 3, 4, 5, 6. So for 80, it would be 0. For 60, it would be 1. Just tell me if I did anywhere wrong. Okay. For 70, the previous greater element would be 1. For 60, previous greater element would be at the 1. For 75, the previous greater element was the 1. I also did sometime wrong, guys. So that's what we need to look. For 75, first previous greater element, it would be 0. Correct, guys? These are the point where we have to stop. Now we just need to do very simple thing, guys. Very simple thing, which is previous greater element minus index plus 1. Previous greater element minus index plus 1. Now let's try for anything. Let's try for 75. So the previous greater element is no, I think we did something wrong here. Oh no, index minus previous greater element. Wait. Right, guys? 1 minus, yeah, index minus greater element. Let me think. 1 minute. Let me think, guys. Let me think. So for 5, how many elements we will be considering? 1 is this one, 2 is this one, 3 and 4. 4 element we need to consider, and we are getting a previous greater element at 1, correct? And its index is 5. So 5 minus 1, it would be 4. 5 minus 1 would be 4. Is it giving like this only answer? 4 minus 1 is equal to 4 for 60. Let me see first if I'm doing anywhere wrong. Yes, for 4th I did wrong, right? Yeah, for 60 I did wrong. I taken it 1. Oh yes, it would be 4. See, I also mistake. I already make these mistakes very occasionally. So this is 3 is there. For this is fine. Yeah. So I think we can get answer very simply, guys. I think simply index minus PGE. We do not need to do plus 1 also. Just see. Let's see. So 6 minus 0, it will give us 6. 5 minus 1 will give us 4. 4 minus 3 will give us 1. 3 minus 1 will give us 2. 2 minus 1 will give us 1. And 1 minus 0 will give us 1. And 0 minus 1 will give us plus 1. You guys see? This is only we need to do. After finding out previous greater element, we need to run a loop where we need to subtract index minus previous greater element. And that's what our answer is. And you can simply see, once we do 5 minus 1, we'll get 4 elements only. This one, this one, this one, this one. 4 elements. So this is the formula here only. Index minus PGE. Understood, guys? Index minus PGE. So first we need to find out the previous grid element. And here you can use the same logic. If duplicate is coming, you just need to skip it. You just need to pop it. There here, no change in the previous code. Whatever you did in the previous code, no changes in that. Once you find it out the previous greater element index array, you just need to use the at the end that index minus previous greater element. Okay, and these things no need to remember anything. You can just calculate these things and then find it out. Earlier, see, I was writing previous greater element minus index plus 1, but then I realized no, not needed here in this case. See, so because we can automatically get the index and this answer directly with that. Yeah. Anyone wants me to explain it again? NGE next. Yes, lot of things because that's why we have started with that. All four will be used. Next greater element, you can see now previous greater element is also used. Before this we have used next lesser element and previous lesser. See, all 4 scenarios we have used. Correct? Let's see some more questions now. And if you guys want to see the code of this, code is already available in the stock span same branch. You can see first you can see here. First we are okay. This is actually okay. Let me explain this also to you. Okay, so guys, one thing here. What is that? Yes, we have to know where to use them. Yes. So guys, one thing. Did you guys want to know about the how can we go for index scenario? Because in the first day, I have only showed you to insert elements directly into the stack. Do you want to know about the index part also specifically, or you guys are aware of that? If you want to look for the index part, So we just simply need to do this line, right? If we want to do, like, if in the stack, if we have index of any element, so let's say if the price is an array, so we just need to do this, right? For finding out the index, stack dot length, because this part will give us index, top element of the stack, and that would be our index, and then we can look into the price array. Did you guys want to like see this thing? Because see, this is one way to find out the index in the stack, and another way is this, which I used in the span, where what I did, I created a separate pair object for just inserting into stack. Earlier we were just simply inserting the value, but now we need index also. So that's why what I did, in the pair I created both things, value and index. And then you can see every time wherever I'm pushing that pair in the stack only. You can see wherever I'm pushing at the end, only we need to push in the stack, right? I was always pushing that element, new element with the index. But this is like little bit taking extra space. This is taking extra space, but you can do the similar thing with this only for getting the index. That's why in all of the next problem, you can see in the sub array minimum also, for fetching the peak, you can see I was using a stack length minus one everywhere, or directly stack length minus one, just for fetching the index. And you can see at the end I was just simply pushing the index, not pushing any pair, not using any extra space. So I was just pushing both of the things in the chat, in the GitHub, whatever way you guys want to go. But yeah, go with the stack length minus one. It will not take any extra space. Yes, instead of top. Yes. Yeah. Okay. Then it's fine. Then this is the similar code which we have done earlier. See, we are checking for greater equal. You can see here, we are checking for greater equal. It means this time we are not looking for any equal condition or anything like that. We are just going to we are just going to pop everything till we got the greater element. So you get later how to get that element if you use that pair class. In the pair class, you see, for getting the element, you have this val, right? You see, stack dot length minus one dot val. This is the dot val. This will give us value, and index will also be there. You see, stack dot length dot. So right at the any of the position in array, it will have now object. In that object, there will be two properties. Okay, Likit? Yeah. Understood now? Are we good with that now? How to implement stack by using linked list? So it's easy, right? You already know all the operations in linked list, right? Insert at bottom, insert at top, insert at end, insert at start, insert at middle. You already know all the operations of linked list, right, Deepak? And you know now the stack also has two operations, right? No, I'm asking about elements other than top. Other than top, but you cannot access element other than top in stack, right? That's very separate topic, Ankit. We'll discuss sometime else. Let's understand what Likit is asking. We cannot access any other elements, right, other than top, Likit, in stack, according to stack. If it's not a stack, then you have to know the index, right? With the index, you can easily access it. Stack 0 dot. Simply, you can access any element, right? See, if you are not thinking it as a stack, the stack is an array. You can do stack 1 dot val. Very simple, right? Then you can do stack 1. If you are considering it as a array, you can index. In the value, you will get the value in index. Say array, right? Okay, let's move into the next question, guys, which is very relatable with the sub-array minimum. With the sub-array minimum, which we did in the second part, very relatable. Let's look into the next question, guys, which is also very hard question. And I have seen people ask it in big organization. And after this question, that definitely has been asked in Google only. After this, the question which we had, maximum area histogram. So let's quickly understand this question also. So let's draw this diagram, what they are saying to us. So let's read it. So given an array of integers height representing the histograms bar height. So these are histogram one by one. These are all histograms. So we have been given one height array, and we got this histogram height. You can see these numbers are histograms height, where the width of each bar is 1. So जितने भी bars हैं ये, जितने भी histograms हैं, they have equal width, which is 1. So we have to return the area of largest rectangle in the histogram. So we have to return the largest rectangle in the histogram. You guys have already done the minimum part. Okay, I have the answer here. Wait. I should. You guys have already done the minimum part. I am sure you guys would be able to see the something relatable here. But let's draw it. Let's draw it. So we have been given one histogram, guys. Let's draw the similar histogram. So it starts from 2. So this is histogram. When I created this diagram, this is histogram, which is right now it's 2. What is next one? 1, 2, 1, 5. 5 is there. Sorry for the drawing, guys. 6 is here. 5, 6, 2 is there. Not good at the drawing, guys. Okay. And then 3 is there. Okay. They are saying this is one histogram, and they have given us one height array, which looks like this: 2, 1, 5, 6, 2, 3. Okay. And they are saying the width here, it's 1. Okay. Every histogram has width as a 1. And guys, let's remove the word histogram from here. Let's consider these are the buildings. Okay, these are the buildings, and we have given the height of these buildings. Okay, now does it make sense? Every building has height, every building has a width. Does it make sense? Every building has height, every building has a width. Correct. Now they are asking us, we need to find the greatest rectangle. We have to find the area of largest rectangle. We have to find the area of largest rectangle in the histogram, or largest area, or let's see, how can we understand the largest area? Let's pick any of the element from here. Like, let's pick this building. I am picking this building, and I want to know how much I can expand this building to its left, to its right. That way only we can find the rectangle. That's way only we can find the rectangle. So we need to find out how much we can expand this building to its left, and how much we can expand this building to its right. Okay, so let's see how much we can expand it. So let's see, if we are having a bigger height, it means we can easily expand it. Okay, we can expand it till this building, we can expand it till this building, but we cannot expand it now here, for because of 1. Correct, guys? So we can only expand this building onto its left till here, and same goes for right side. So we can only expand it till here. Correct, guys? You just think about it. Like, there are 6 buildings which are all connected. So whoever is the lesser height, you can only expand that building till all the buildings, right? Just visualize it in the real world. there are 6 buildings are standing in front of you, all has different height. So you can expand which building more, which has lesser height, right? Which has lesser height, correct? Everyone agrees with that. So let's see how much area it will has for 2. So we can see, let's calculate the width of this building. So 1, 1, 2, 3, 4. So for 2, width is 4 and height, as we already know, it's 2. So the area would be 8. Let's look for any other building, guys. Let's look for 1. Why not? Let's look for 1 because 1 could be expanded everywhere. Agree, guys? 1 could be expanded in all the buildings because this is the smallest height building. So now for 1, the area width would be 1, 2, 3, 1, 2, 3, 4, 5, 6. For 1, width would be 6, height would be 1. So it's a 6. Now let's look for 3. We can't expand 3 anywhere because it's into the left of it, it's smaller building, into a right of it, it has the like no building at all. So we can consider it as a 4, like the next index, whatever the index is there. We are already always considering after that the last index, right? So what would be the index here? Or just avoid it right now. When we will solve it, at that time we'll consider the index. Let's look for 5. Let's look for 5, guys. So 5 could be expanded. 5 could be expanded into this one, into the 6 one only. Right, guys? 5 could be expanded only in this one. So now for 5, let's consider. For 5, width would be 2 and height would be 5. Answer would be 6. Answer would be 10 here. For 6, it cannot be expanded anywhere. So width would be 1, height is 6. So area is 6. I think we have calculated for everything, right? 1, 2, 1, 2. For this 2 also, we can't go anywhere. For this 2, this building can also not be expanded. So now our answer, I think they are asking maximum, right? So our answer should be 10. Let's see our answer. Let's see our answer. Yeah, you can see our answer is 10. For 2, width 5. For 2, width is 5. Yeah, you see, for this 2, I'm talking about this 2. Sure, I'm talking about this 2. So let's see, width is 4 or 5. Width is 4, not 5. Suraj, for 2, you can see width is 4, not 5. Understood? Suraj, asking to you. Understood? Width is 4. Okay. So you can see for 4, where we can extend this building to left. We can extend easily to this building because it's having height 6. So we can easily extend this one or expand this one. Same for 5. We can easily expand this one also in the 5 also. But we cannot expand in 1 because its height is lesser. So that's why we cannot expand this building in this one. Same goes for the right side. We can expand it into the right side also. And then you can see width is 1, 2, 3, 4. Got it? I know a lot of people has already answered. Likhit has already answered. So yes. So I think now you guys can understand this one is how it is similar to the sub-array minimum. Can anyone guess it? I think if you guys have already seen the Likhit answers, so you already know that. But if you are not, just answer it. Can you see what is the logic or how it is related with the sub-array minimum? I think you guys have guessed it. We have to stop it wherever we got the first minimum. Wherever we are getting the minimum at the left side, wherever we are getting the minimum at the right side, we need to stop it there. We need to stop it there. Agree, guys? That's what we are doing here. You can see for the 5, when we are going onto the right side, we only went till 6. As we got height 2, we stopped its expansion because it cannot expand it, right? Another building is with the size 2 is standing here. So that's why at the right side we need to find out the minimum lowest element, and the left side also we have to find the minimum element. And that's a similar thing which we have done in the sub-array minimum problem also. We have done the sub-array minimum similar problem. Agree, guys? Everyone understood? We need to apply these two logics. Yeah, sub-array, because in sub-array actually we need to think about the how can be maximum possibilities is there. That's why. But let's calculate. It is not fully, it's not fully equal to sub-array problems. The similarity is we need to find the previous left element, previous lowest element, and next lowest element. Similar way in both places. Let's find it out here also. Let's take our array 2, 1, 5, 6, 2, 3. Right? Let's first write the indexes of them, which is 0, 1, 2, 3, 4, 5. Right, guys? Now quickly tell me right side lowest element for each array. And you have to tell the indexes. Guys, always remember, you have to tell the indexes here. Can anyone tell me quickly all the indexes for right side? I want you to first calculate these things while just visualizing. I know I also done the mistake, but I want you guys to be perfect here. That you guys could easily calculate the right side, right lowest element index. You have to go to the right side and find out the first lowest element index. First lowest element index. Okay, you guys are taking time, so let me write it. So for 2, it could be 1. It would be 1 only. So index would be 1 here, right? For 1, lowest first element. It's not here. So let's take the length of array, which would be 6. Correct? Which would be 6. Let's look for 5, the lowest element. First lowest element, which would be 4, right? 4, right? And let's look for 6. Yeah, again 4, right? Let's look for 2. No element. It's 6. Let's look for 3, 6. You guys tell me, I did right or wrong anywhere. So Arad has given 1, 6, 4, 4, 6, 6. Yeah, it means I did wrong. I did correct. As Suraj is giving -1. Okay, so he's taking 6 as a -1. That's fine, Suraj. Yours is also right. But you need to take the next index. Whenever we are looking at the right side, we need to take the last index. Okay. Now let's calculate the left lowest element index. Left lowest index. Now we need to take the -1. Okay. So first is -1. For 1, there is no, so -1 again. Let's look for 5. 5 ke liye 1 hai. 1 is there. For 6, 2 is there. For 6, 2 is there. For 2, 1 is there. So 1 will become here. As an index, 1 will become here. For 3, 2 is there. Sometimes I got confused. I just put 1 here. So I will, for 3 also I will put 1. But that's wrong. Everyone understood both things? Everyone understood both things? Let me compare it also. So Likhit and X has provided. So -1, -1, 1, 2, 1, 4. Okay, it means mine is also correct. Okay, guys. So now, guys, let's find out the width first. Let's find out the width. So let's see. Let's calculate for 5 first. So for 5, where is our 5? This is our 5, right? Yeah. So for 5, the right side index is coming 4, and left side index is coming as a 1, right? So now you can see 4 minus 1 will give us 3, which is not correct. Our width is 4. So we need to do +1 here. Understood, guys? You can see with the visualization only. So right side index is giving us 4 and left side index is giving 1. So 4 minus 1 is 3, which is not correct. You can see we are having the 4 width. So that's why 3 plus 1 is equal to 4. And same logic will work for everything. Let's consider for 6 also. Let's consider for 6. So for 6, not for 6. Yeah, for 6 only. Where it is coming 2. For which value 2 is coming? For 6 only 2 is coming. For 6. Let's calculate for 1. We'll get more values, right? Then only we'll calculate. For 6 only we'll, okay, for 6 you want. Let's go for 6 only. So for 6, what is the right value coming? For 6, the right value is coming 4, which is this one, right? This index. So right value is 4, and left is coming this one, 0, 1, 2. You can get it from here also. For 6, yeah, for 6 it is coming as a 2. So 4 minus 2, 1 minute, 4 minus 2 is equal to 2 plus 1. Something is wrong. One minute, guys. Let's think about it again. I think we are doing something wrong here. Let's see. I think we need to include our indexes also, something like that. Let's calculate it one more time. Let's try it. So if we are looking for this one for 2, which index is 5, let's see if we need to use index or not. What's the index? 0, 1, 2, 3, 4. Let's see, 4 and 5. Let's calculate it. So for 2, I'm saying I'm right now just taking 4 and 1. For 2, I'm talking about this 2. I'm talking about this 2. I'm talking about this 2, right? So yeah, this is 6, this is 1. I was taking wrong actually. Yeah, it's not 4. I'm just taking this value, right? This 6. So I think we need to include the indexes also. But think about it. So 6 minus 1 will give us 4. 6 minus 1 will give us 5. And if we do 5 minus 1 is equal to 4, this could be one logic. Let's think. Let's think if it is working everywhere or not. I am saying, guys, I have taken right index minus left index minus 1, which is giving me 4. So right index minus left index minus 1, which gives us 4 for 2. Let's look for 6 now. So for 6, let's look for 6. This is 6. So 4 minus 2 will give us 2, minus 1 will give us 1. Okay, for 4 it looks good. This logic is working. Let's look for now 1. Let's look for element 1. Okay, so for 1, the element is 6. Okay, it's 6. Correct. And the right side is 6 and it is minus 1. Okay, so right 6 minus 1 will give us 7. 6 minus 1 will give 7 and minus 1 will give us 6. Yeah, I think this logic is working, totally working. Guys, this logic is totally working. For 6 also it is working. Let's look for 3. Quickly look, let's look for 3. For 3, 6 and 4. So 6 minus 4 will give us 2 and minus 1, 1. Yeah. Totally agree, right? So this logic is totally working, guys. We have to take the right side index minus the left side index minus 1. So height multiply by I minus LLE plus height multiply by RZ plus. Sorry, mistakenly typed. Okay. Understood, guys? This logic is totally working. So that in that way, we will find out the width. So let's calculate it. Let's calculate it. Let's calculate the width now for each element. Width. And our logic for width is R minus L minus 1. This is the logic which we are going to use for calculating the width. So let's see. R is 1 here. Minus 1, we'll add it. It will make 2. 2 minus 1 is equal to 1. You can see 1 minus 1 minus 1. This will be added. So 2 minus 1 will give us 1. That's why I've written it 1 here. I hope everyone understood this thing. Now let's look for this one. So 6 minus 1 will make it 7 and 7 minus 1 6. 4 minus 1 3, 3 minus 1 2. Let's look for 5. 5 will give it 2. Let's look for this one. 4 minus 2 will give us 2, will become 2 minus 1 1. 6 minus 1 will give us 5. 5 minus 1 will give us 4. Correct? 6 minus 4 is equal to 2 minus 1 1. Guys, we got the width and now we have the height. We have the height, we have the width. We just simply need to multiply it. So multiply this. Right, height multiply by width. So 2 multiply by 1, 2. 1 multiply by 6, 6. 5 multiply by 2, 10. 6 multiply by 1, 6. 2 multiply by 4, 8. 3 multiply by 1, 3. What is the maximum? 10. That's our answer. I hope you enjoyed this one. Okay, sir. Why RLE minus LLE minus 1? y minus 1 at last. Okay, sure. So Hariharan, let's see. Let's draw it again. Yeah, let's draw it quickly. No problem. So this is our 2, this is our 1, this is our 5, and this is our 6. Right? What was next? 2 again. 2, sorry, here 2. 2 is here, yeah. 2 again and 3 again. 3, sorry. Okay, Ariel? Yeah. So see, guys, let's take the value also. 2, 1, 5, 6, 2, 3. Okay. So, Hariharan, so for 2, you tell me what would be the lowest previous element. Let's write the indexes also. What would be the lowest previous index for 2? Lowest previous index. Hariharan, you tell me. It would be 1. Great. Because this would be the place where it will be stopped. Right? Expansion will stop here. Okay. Now you tell me the right side lowest index. Hariharan, right side lowest index. It would be 6. Great. Right, guys? So now, when we have these two things, now you tell me what would be the width for two. If we expand this building on both sides, so you can see we can expand this in here, right? Because 6 is greater height, we can simply extend this. We can simply extend this one also, but we cannot extend here. It will be on roof. Like this is the building which has height 1 meter. So if you will extend this, you will go into the roof. You will not be in the building, right? So that's why we'll stop this expanding here. Understood, Aryan, this line? Understood this one? The left side expansion. Let's expand on the right side. So we expanded here also. So now you can see, according to the visualization, we got the width as 4. Width as 4. Correct? So now we have the the right side index which is ending at this place, and left side index which is ending at this place. So if we subtract this one, if we want to find out the middle element of between these two index, so we will simply subtract it. 6 minus 1, which was giving is 5, right? Which was giving us 5. It means when it is giving us 5, it means it is including 6. If you know about like the subtraction, in subtraction, when we are subtracting 4 minus 2, 4 minus 2, it means it is adding it, at the end, it is taking some of the last, like it is including the 4 also, right? If I do, like if there is number 2, 3, 4, correct? And if we do 4 minus 2, it will give us 2, right? So it means we only looking for 3 here. So what we will do? 4 minus 2 minus 1 will give us only 1 middle element. So that's what we are also doing here. We want to look for 1 and 6, the middle element. So once we subtracted, 6 minus 1 is equal to 5, and then we did 5 minus 1. Then we got the width as 4. So that's why we are doing the minus 1 in everywhere. We want to do the find out the middle element. We want to find out the middle element. Understood? Everyone understood? Okay, so let me show you the code also very quickly. Same code, guys. Nothing different. And you know, this question is actually very important also. Maximum histogram area. You see, first I am passing to the left smallest and right smallest. Same like the minimum, array minimum. I passed but both places my height array. You can see the same code. For left smallest also, I'm checking same thing. Checking if it is greater, do the popping there. If it's not, just do the insertion for the left. And you can see it is starting from I is equal to 1 because we are starting from left side. If I go for the right side, it's starting from n minus 2. And you can see at the end, I'm doing the reverse. This thing you need to remember, code you already aware of. And once you find out the left and right, you need to calculate the width now. For width, what I did, right minus left minus 1. Now we got the width from the right minus left array. Once we got it out this, now what we need to do? We need to multiply with height array, with our original array. We have to multiply width and original array. So that's what I'm doing. We can see height multiply by width, and then I'm checking if my answer is maximum or not. Checking my answer is maximum or not. Understood, guys? So let me copy paste this one. It's the same, I think. Yeah, it's the same code. Nothing different. Okay. So yeah, it's the same code, guys. I want you guys to do the, because see, if you do the array minimum and then jump into this one, you will not find any difficulties. You just need to solve one question. Everywhere you need to copy paste. Just need to change the logic. But I will say to you every time, try to solve it. Okay. Let's jump into the next question, which is, you know, which is using this question as a subpart. This question, maximum area histogram, as a subpart. Let me show you. And that question is asked in Google, guys. The next question which we are going to look into, that question is asked in Google, which is the same like I think maximum area in rectangular, but in binary matrix. Let me jump into the next question, guys. This question is also important actually. Maximum area histogram. This one is also hard. So if you got in any interview, so definitely they are looking for you to find it out that this is a stack problem. You need to find out left and right one, and you will write it. You have to write the code also. Yes, that's what I want you guys to crack it. And the next question is also asking Google. So definitely, next question you guys will also know that, and you guys will also crack it. Maximum rectangle in a binary matrix. Let me search it in the lead code. Maximum rectangle. Yeah. This is also hard question, and this is definitely asked in Google. You will check in the you will check in that, so you will find out, right? So let's see, guys, what they are giving. Then we will jump into that one. So now they are giving us row and column in binary matrix, and they are saying this row and columns are filled with zeros and one. Okay, and they are saying we need to find the largest rectangle again, which is containing only ones, and after that you have to return its area. After that you have to return its area. Okay, so let's draw it. Let's draw the same one. It's bigger, by the way, but let's draw it. Let's draw it. So let's take our matrix, which is 1 0 1 0 0 1 0 1 1 1 1 1 1 1 1 1 0 0 1 0. Okay, guys, this is the matrix, and they are saying we need to find the space where where all ones have a rectangle. If we add all the ones, then we should have the bigger rectangle. So let's start from first row, guys. Let's start from only first row. So let's put it the indexes also. 0 1 2 3. This is our rows. 0 1 2 3 4. These are column. Okay, so right now I'm just looking into the first row. Okay, so we need to check for those places where we got the 1. Okay, so if we talk about only first row, only first row. Okay, if I'm saying first row, so let's take it out that row from the picture. So 1 0 1 0 0. If this is only the row which has been given to you, yeah, we'll see that, we'll do that. Yeah, so if we have to find out the this only. Okay, and so you just like do not go into the logic, just tell me what would be the, like how what would be the maximum rectangle here, what would be the length of that maximum rectangle here, what would be like, see, because see the question was We need to find they are saying we have to find the largest rectangle containing only ones and return its area. Okay, so like how many rectangle we can create here? How many rectangle? So yeah, just tell me how many rectangle we can create here. Everyone answer it. How many rectangle we can create it? We can only create two rectangles, right? This is the first rectangle. This is the second rectangle. What would be the maximum area? Because they have only one element, so the maximum area would be one here. In this case, maximum area would be one. Maximum area would be one here, right? Let's include now second row also. Now let's include first and second row. Now let's include first and second row. Then you guys tell me what would be the, how many rectangle would be there, or what would be the maximum area. Because I want you guys to visualize it something here. So yeah, now you guys tell me how many rectangle could be possible here if we say that. Because we are, how can we create the rectangle? We have to combine all the one. We have to combine all the ones. So like you can see here, we can create, I think, this much, this one as a one rectangle, right? We can create this one as a one rectangle, I would say, right? And this one could also be one rectangle, correct? These two could also be one rectangle. But yeah, the maximum, I think, the minimum, I would say, yeah, minimum these three we can see here. And the maximum area, if we talk about, so maximum area, this one will give, because we are looking for maximum area. So this one is the one who will give us the maximum area, which would be 3. Right, guys? This would be the maximum one, which will give us the area as a 3. Am I right or not? Am I right or not? Yes, right? So let's take now third row also. Let's think about taking the third row also. First row and third row. First and second and third, all 3 rows. So 1 0 1 0 0 1 0 1 1 1 1 1 1 1 1. Okay, now let's talk about the maximum area, maximum rectangle I am looking here. I'm looking for the maximum rectangle here. So I think I can directly see this is the one which is the maximum one here. If you draw for any other, you will not find any maximum rectangle here. And the area is 6 here. And that is our answer only. You see here it will be 3. Here it will be 2. Oh, 1 minute. We have this one also. Yeah. But yeah, still it's 5. I didn't observe this one. But this is 5. It's still lesser than 6. We have 3 here. We have 4 here. Yeah. The greater one is this one only, which will 1. This one. I know I've done a lot of dotted there, but yeah, this one is the greater one. Understood? Everyone understood? Let's take the fourth one. Why not? Let's do it here only. Why we are going anywhere else? So let's take the fourth one. See, these zeros are not going to contribute anything here. So again, this would be our answer only. You guys just visualize it here. Do you want me to draw it? But yeah, you guys can visualize it. Anything bigger we are getting here. Anything bigger? Explain 2. You mean first and 2? First and second row? Suraj? First and second row? Explain 2. Explain 2, you mean first and second row combination, right? One, two, three. 1 2 3. Okay, this one, right? Yeah. So see, okay, let me draw it again. Yeah. So we need to find the maximum rectangle here, where we can create the maximum rectangle. So let's start from here. and those maximum rectangle only should have one. So this is the first maximum rectangle, correct? Then we can see this is the second maximum rectangle, which is giving us 5. This one is giving us 3. Then we saw one more rectangle, which is this one, which is giving us 6. Then we saw this one also, which is giving us 3. All the ones in this 3. And then we have this one also, final smaller one inside that, which is giving us area as a 4. So that's why I was saying the maximum is here 6. Understood, students? Got it? Okay, guys. Now let's relate this whole with maximum area histogram. Let's relate it with that. Very nice relation is there actually, you know. Let me show you how. So see, first relation which you are getting in the histogram, they were also asking you to find out the maximum area, right? And here also they are asking you to find out the maximum area. Agree, guys? In the main phone में main class attend कर रहा हूँ अभी. अच्छा, ये you are writing it here or you are writing to somebody else? You typed it here. Okay, that's fine. So see, guys, let's relate it with the maximum area histogram. In the maximum area histogram, they were also asking about the find out the maximum area. Correct. Here also they are asking about the maximum area, but the difference is in the in the maximum area histogram, they were giving only 1D array. They were giving us video gone. Everyone is fine, right? Who was saying that? Nazmeen, just refresh your browser. Just refresh your, sorry, this particular tab. So you will get it back. Okay. Okay, so so what is the difference there? Now they are giving us 2D array. But in the maximum area histogram, they have given us 1D array. So guys, that's what we are going to do. We are going to convert this question into a 1D array. So let's see 10100. So we'll take this as a building, this as a first array, and take this as a building. So this is 1, this is 0, this is 1, this is 0, and this is 0. And everyone has a width of 1, and height also 1, 1. Correct? In the maximum area histogram, we have the similar scenarios. Right, guys? In the maximum area histogram, we also have the similar scenarios. So what would be the maximum area here? According to you, what would be the maximum area here in this histogram? If we have a histogram like this, what would be the maximum area here? What would be the maximum area? Sharad, what would be the maximum area here? Everyone, what would be the maximum area here? Yes, it's 1 because this is the one building only. This is the one building only. We cannot expand it to this side, not we can expand it to this side. Same for this building. We cannot expand it this side. We cannot expand it this side. So that's why the maximum area is 1 here. Everyone understood? Everyone understood? Yeah. Okay. Now, guys, just little bit thinking we need to do. Now, while taking the second row, we need to take the both rows together. It means we need to add it. So we need to add it. So it would be 2, 0, 2, 1, and 1. Because guys, we are now taking these two buildings. You can consider these two buildings we are taking. So we need to add those as a buildings. Okay, so let's draw this. 2, 0, 2, and then 1 and then 1. Correct, guys? 1, 1, 2, 2. 0, this is 0. This is like, I'm not writing anything there, but you guys know that this is 0. So that's what you need to do, guys, because we need to make these two rows in 1D array, because you know that in the maximum area histogram, we were looking for 1D array only. So that's why we combined these two array into one array, and which was 20211. Now guys, tell me what would be the maximum area here? What would be the maximum area here? You guys tell me what would be the maximum area here? Yes, height plus next row. Yes. So maximum area would be 3 here. Totally right. Maximum area would be 3 here, because we can expand this one into this last one. Yeah, this one into this one, and then here also. So you can see this last one, or anyone, this one also can be expanded here and here. Right? So this one could also be expanded here and there. So maximum area would be 3 here. Now let's take 3 rows. Let's take third row also. So it would be 3, 1, 3, and 2 and 2. Correct, guys? 1, 1, 1, 1, 1, 1, 1, 1, 1, 3, 1, 1. So these are, you can consider these are just the building, guys. These are just the building. You can combine these buildings like this. Correct? These are just the buildings. 1 minute. Yeah. So these are just the buildings. Correct? Right? And these are just the, you can consider this is roof. This is just the chat. Chat hai apni ye. ठीक है? So 3, 1, 3, 2, 2. Let's draw this one also quickly. So 3, 1, 3. Sorry for this little bit extra height. I've given it 2, 2. You guys tell me quickly the area, the maximum area here in this building or histogram. You guys tell me the maximum area here. 6, right? The maximum area would be 6 here. Okay. Now guys, for the last row, for the last row, for the last row, guys, you cannot hang your building. You can see 0, it means your building is hanging. Your building is hanging. So you cannot hang your building like this. So that's why for the last row, you do not need to add wherever 0 is coming. Just logically think. You cannot hang your building on anything like that. This is like your building is hanging on the air. This is not touching the root. This is not touching the ground. So wherever we are getting the 1 at the last, this means it is touching the ground. But wherever we are getting 0, it means it's hanging in the air. So that's why we'll do just addition for these things. 4, where we will find 0, we'll keep the 0 like that. Same goes here. Found the 0, we'll do the 0 here. We got 1, so we'll add it. 1, 2, 3. And we got again 0, we'll put the 0 here. Okay, guys. So that's what we are going to do it here. Let's calculate the same here also. Again, 4, this is the first building. Again 0, 0. Then we got 3. And then we got the 0 again. So you guys tell me what is the maximum area again. First, you guys tell me what is the maximum area here. 4, 3. It would be 4. It would be 4. So now you can see, you can compare all the things, and the maximum you got 6. Maximum you got 6. So let me see, floating Tesla buildings. Oh yeah, he is planning something like that. 4. Then for every row we have to do that index, that 0. Yes, totally right. Index has told correctly. Sorry, index I'm saying. Likit is saying correctly. So guys, wherever in the row you are getting 0, you will put there as a 0. You can see everywhere we have already done the same. You can see for the first row, for the first row you do not need to do any addition. But let's see from the second one. Wherever you are getting 0, you will put directly 0 at that place. It will always start from here. Wherever you are getting 0, we will directly put our result as a 0 at that place. Not only for the last row. Wherever in which row, wherever you got the 0, you will simply put there as a 0. You will not add it from the previous row. You will simply not add it from the previous row. Okay, just you have to skip wherever you are getting the 0. Okay. Yeah. Let me see how much time we have. Okay, we have only 5 minutes. So let me quickly show you the code also. In meanwhile, anyone has any question on the understanding part? The 85, it's 85. Anyone has any problem in understanding? Let me know in the chat. So it's very simple. You have to calculate, you have to use the minimum area histogram as a sub part of this problem, right? And then there are two things you need to remember. First thing, you have to start from first row. You have to calculate the minimum area histogram for that. Then for the second row, you need to add the previous row. You need to add the previous row into that. While you are adding, if you got 0 any place, you will put 0 directly that like that. You will not add anything for 0 wherever the value is 0. No, we are not calculating last row separately. We are calculating a similar way. Every row will be calculated in similar way. Every row will be calculated in similar way. Wherever 0 is coming, I was just explaining you, because in the last row I just explained you this logic. In last row I explained you this logic, because we cannot keep our building hanging. We cannot keep our building hanging. That's why only in the last row I explained you this logic. But this will happen in all the rows. Wherever you find the 0, you will keep the 0 in that way only. You do not need to change anything there. Understood, Hariran? So let me quickly show you the code also. Okay, so what will be the answer? Answer will be 6 here. That was our answer, right? Yeah, 6. You see, the maximum you got 6 here, right? This one. Understood, Deepak? So answer would be 6 here. Let's quickly see the solution also. So this is, guys, that logic, minimum area histogram. You can see again same logic, left, right, then again subtracting and then multiplying temp. That's what we did in the minimum area histogram. Same logic is written here. First calculate right, then calculate left, then do the subtraction, like subtraction -1, where we calculate the width. This is the width we are calculating, and then after calculating width, we are just multiplying with our element array of I, multiplying with that, and then simply returning the answer from here. Okay, let's see how we started. So first we have calculated for the first row only, matrix 0. You can see I'm just simply passing the first row, matrix 0, in the MAH. So first I calculated only for this one, 1 0 1 0, only for this one, 1 0 1 0, only for this row, without any, because we do not need to add anything there, right? Now what I did I am taking that as my answer, because this is the first row. I'm taking that as my answer right now. Then what I did, I went for the next loop. So you can see Wherever I'm getting 1, I'm just adding the previous row, I minus 1 comma j. I'm not adding anything for 0. Wherever in the matrix I'm getting 0, I'm not adding it out. And once the j loop is completed, I'm just simply passing the same matrix. You can see I'm starting my loop from 1. So once the j loop is completed, it means in j loop I'm simply adding everything. In the jth loop, I'm simply adding everything like this 20211. Once I added it, I'm just passing this row to the MAH function. You can see I'm simply passing that row to MAH every time. And once I'm passing it out, I'm just comparing my answer with the first one, and just comparing it, whatever the max is, that would be my answer. So this is, guys, the Google question, which they have been asked in Google question, and I'm thinking they would be giving us for solving this question minimum, I think 30 minutes to solve this question. So now you guys know this question. So in somehow, if you got this question in an interview, I'm hoping you guys would be still spending 30 minutes, but you got the logic in 10 minutes. Right, guys? Will you be able to solve it now? Yes. See, yeah, do the practice. Yes, like, yeah, do the practice, but the assignment question are very necessary. Go for the second assignment question, which I told you, sub array, because these things you will remember now, right? You can practice it. Everyone, I will say that practice it. Yes, definitely. So everyone, please practice these problems. I already pushed all the code in Stack or in the GitHub, sorry, where you can see the answers. But the assignment questions are interesting. The second assignment question, where you have to find out the sub-array maximum range. That question is very similar to sub-array minimum one, but you have to just think little bit extra there. You have to think little bit extra there, and you will find out the answer. So just practice that question. And apart from there is daily temperature question is also there. That's also similar. Somehow you need to read the question and understand, like stock span. As we have understood the stock span, in similar way the third question is there, daily temperature. And the first question in the assignment is next greater element 1. Like we have solved the next greater element, which was easy one. In the next greater element, if you guys remember, we were looking into the right side every time for the next greater element, but there is some extended version of that, and that extended version is, if you are not able to find it into the right side, also look into the circular way and come back to the previous elements also. So like this, just the extended version of next greater element. So like this, 4 3 2 1, right? So next greater element 1, then I will also solve it with next greater element 2. So for 1, the answer would be, let's consider this as a 4, 0 1 2 3 4. So answer would be 4. I think, yeah, answer would be 4 4 4 only, because there is no next greater element, right? Answer would be 4 4 4. I think I should change the example. Otherwise, here also, if I see with a circular way, again I see 444 will be the answer. No, no, no. Actually, this is index 4. Let's take another, otherwise you guys will confuse. Let's take another example. This example will confuse you. Okay, let's take random actually, not thinking about an example, just simply doing it. Let's see if we get the result. So for next greater element, so for 2, it would be 8. I'm writing element right now, not indexes. For 8, it would be 5, no, 1, no, 6, no, 7, no, 4, no. So let's write -1. Okay, we are just taking element this time. For 5, it, it would be 6. For 1, it would be 6. For 6, it would be 7. For 7, nothing is there. -1, and 4, -1. Am I right, guys? This would be the answer. Am I right, guys? This would be the answer. Now the extended version is saying if we are not finding any answer on the right side, you can come back to the starting point. You can come back to the starting point. So let's see again. For 2, we got the answer 8. For 8, let's see. We didn't find anything. Let's come back to the previous. Still we didn't find anything. So for 8, it will still be -1 because there is no greater element than 8. So that's why if we already traverse whole array, but we didn't find anything. But let's see for others. For 5, 6 will be there. For 1, 6 will be there. For 6, 7 will be there. But for 7, now guys, for 7, 8 would be there. For 4, 8 would be there. So this is the extended version of next greater element. This is the extended version of next greater element. Now you are coming back. Now you are coming back. For 7, you have already taken a look on the right side. You didn't find any greater. Now you are coming back to the previous from in the starting part and then checking it back. Yes, circular. Yes, you are now moving into circular. And when you find after doing the circular, you also didn't find any maximum, you will do -1. For the 8, you already gone right side, you didn't find any greater, you came back to the previous one, we still don't find any greater, we will do -1. So these are the 3 examples, guys. I want you to start from the temperature one in the assignment, which is little bit easy, like stock span. Start with that, then go for sub-array range. That is little bit medium, but just relate that question with sub-array minimum. You will get the answer. This one is little complicated, like not complicated, just little bit thinking is needed here. And all these problem has to be solved in with the help of stack only. Okay, guys. So that's all from today. We'll meet tomorrow morning. I think it's very less time for you to practice. I'm not sure you guys will able to do that or not in the very less time. But let's see. But yeah, I think what to say. You guys can tell me if you guys want to discuss this problem in next class, or we can discuss this later also. Hey, you guys can tell me tomorrow. Yeah, that's what I'm saying. Unable to practice in between, sir. So I will talk about the next greater element. Remaining 2, I think later in revision. Yeah, I think in revision also we can do that. Yes, we are going to start Q tomorrow. It will be very like similar like first stack class. You remember first stack class where we simply try to create the Q data structure. That's what we'll do tomorrow. We'll try to create the Q data structure operations. Similar like stack has push and pop, Q also has the similar operations. Try to implement them, try to create a class for that. Those things we'll do in tomorrow class. It will be like not this much, that like this much heavy. I think this was not heavy also, or today's class was also not heavy, right? It was interesting, right? Okay, so let's end it today, and I hope you guys have enjoyed it. I want you guys to practice it now. I have given, because I have not showed you the code. I have not run the coding today, because if I will do the coding, then I think the concept we will be missing here. That's why I have not showed you the code today. But yeah, next class we'll do the coding also for the queues. We'll do the coding in front of us. Yeah? Okay, guys. So let's wrap it today, and then we'll move into our next class. Good night. Good night. Good night, everyone. Good night. Bye bye.